On this channel, we provide useful programming information with practical code examples. This time, it's about JavaScript and WebGL. We will explain in detail the basics of WebGL and how you can utilize WebGL with JavaScript. Enabling subtitles will make the code descriptions easier to understand. JavaScript and WebGL are powerful tools in modern web development for delivering interactive, high-quality 3D graphics in the browser. By using WebGL, you can directly leverage the GPU for efficient rendering and build expressive web applications such as games, data visualizations, and VR/AR applications. WebGL, Web Graphics Library, is a low-level graphics API provided as part of HTML5, used to perform 3D rendering directly in the browser. It is based on the OpenGLS 2.0 specification and controls the GPU from JavaScript. By using WebGL, you can display advanced 3D graphics in nearly all modern browsers without the need for special plugins. To perform rendering with WebGL, you need to understand several key concepts. Like other graphics APIs, such as OpenGL and DirectX, WebGL processes data through a graphics pipeline and generates images on the GPU. WebGL renders using the HTML5 <canvas> element. In JavaScript, you first need to obtain the WebGL context. Obtain a WebGL context from the <canvas> element. This allows you to control GPU rendering through JavaScript. To render with WebGL, you use two types of shaders, a vertex shader and a fragment shader. Vertex shaders calculate the position of each vertex of an object, and fragment shaders calculate the color of each pixel. These shaders are programs that run on the GPU. Shaders are written in a language called GLSL. The vertex shader processes vertex positions, and the fragment shader sets the per pixel color. Here we output red. To incorporate shader source code into a WebGL program, compile the shaders and link them to create a program. Compile each shader and link them into a program. This builds a rendering pipeline executable on the GPU. Next, prepare the geometry data to be drawn and send it to a WebGL buffer. This data includes vertex positions, colors, texture coordinates, and so on. Define the vertex coordinates of a rectangle and upload them to a GPU buffer. Static_draw indicates that the data does not change frequently. Finally, have WebGL perform the actual rendering using the shaders and data. Configure the WebGL rendering pipeline correctly and issue draw commands to the GPU. Here, we clear the background to black and draw a red rectangle using the defined vertex data and shader program. In this code, we set up the WebGL rendering pipeline and render a rectangle. By initializing the screen with GL clear and sending draw commands to the GPU with GL draw arrays, the data processed by the shaders is actually displayed on the screen. With WebGL, you can utilize various advanced features beyond basic rendering. Here, we introduce some of those features. WebGL supports texture mapping, which allows you to apply images or patterns to 3D objects. This allows you to give objects a more complex and realistic appearance instead of simple colors. Load images as textures and apply them to object surfaces to achieve a more realistic appearance. You can use shading models to apply realistic lighting effects to 3D objects. Calculate how the surface of an object reflects light based on different shading models such as Phong shading and Gouraud shading. Compute brightness based on the angle between the light direction and the normals. This is the basis of shading techniques such as the Phong and Gouraud models. Since WebGL operates directly on the GPU, performance optimization is crucial. Using a large amount of vertex data or complex shaders may lead to a decrease in performance. The following are common approaches for performance optimization. Efficient use of vertex buffers. Rather than updating vertex buffers frequently, reuse buffers once created as much as possible. Adjusting the frame rate. Use request animation frame to control animation rendering and maintain an efficient frame rate. Occlusion culling. A technique that omits rendering objects that are not within the view. This can reduce rendering load. Control the rendering loop with request animation frame and efficiently update frames in sync with the browser's rendering timing. By combining JavaScript and WebGL, advanced 3D graphics that operate in real time can be achieved in the browser. WebGL encompasses many elements from the basic concepts of shaders and buffer management, applying textures, to performance optimization, but by effectively utilizing these, you can develop interactive and visually rich applications. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Your support keeps this channel motivated. Please subscribe to the channel.